Yeah, hopefully you can hear me. Thank you, everyone. Thank you, Steven. Thank you, Sven. Thank you, Tony. Thank you, AppDynamics. Yeah, thanks for all Tajawal heroes that they are here today. Yeah, we love you guys. Thank you very much. Good. A little bit about our journey that we started here in Tajawal. The topic that we selected is a little bit reflect what we have achieved over a little bit of probably 2 years that we have been running through. And the topic is basically the startup architecture at scale. How did we basically build a startup architecture from one person probably to 400 people? How did we basically achieve this? What is the cornerstone that we focused on? What's our fundamentals that we followed across our journey? Yeah, so we focus a little bit in a few things that we think they are helpful. We want to share them with you. Yeah, a little bit about myself. My name is Mohamed, as a lot of people know me here. I know a lot of familiar faces here. I can use this one.
Yes, please.
Hello? Better?
Yes.
I can
speak in front of it.
I can sing? No? Okay. Okay. I can't. Okay, cool. So a little bit about myself. Yeah, my name is Mohamed. I know a lot of people here, a lot of familiar faces. Dubai is such a small city. Yeah, I come from. Better? Okay. I come from technology background. I come from Egypt. Have been here in the region for 5-6 years. Have done a lot of different things since I come here. Till I landed basically in Tajawal since we started almost 2 years ago. A little bit about what we believe is our key success is that we bought is not technology first, product enabled by technology. I think this is one of our core fundamentals that we focus onto. And yeah, Tajawal is basically comes from, a lot of you probably not Arabic speakers, so Tajawal means wonder. We took it basically from the word that it's also inspire us. How do we build this? How do we achieve what we want to achieve? So it means go and wonder. And this is probably our vision and our value that we want to provide. So it's a travel sort of agency that provides some sort of inspiration and the normal service that we basically around the region, from booking of flights, booking hotels, packages, etc. pp. In 2 years where we are, basically we run 2 brands now, Tajawal and Musafir. We are part of At-Tayyar Travel Group, so it was a little bit of a transformation program that ran in a corporate company that resulted in an online unit that basically have a vision to also dominate a lot of the Middle East market. We started basically with Tajawal. We have now Al Musafir brand. We have more than 400 people across our offices that span probably 4 locations. We operate in 10 markets, and yeah, we are part of At-Tayyar Travel Group. At-Tayyar, cool. A little bit since we started, so we had a lot of basically not challenges, we call them opportunities, and the key opportunities that we saw as a normal small companies that want to start in the region. The first, probably the biggest, which is building a scalable platform, something that scale. Everyone talking about scalability, but scalability is not just a word. It's a lot of series of action that we do to achieve scalability. And the other part was, of course, getting the team who build this scalable platform, right? So there was 2 parts that we call them agile teams. So also in a modern environment that distinguish us from being a corporate or from being part of a corporate company they have a lot of benefits, like running slowly and delivering legacy systems. Yeah, so we wanted to basically distinguish ourselves from them by building a modern systems and building a lot of this flexibility and agility so we can go through quickly to the market, capture what the value. Then we focus on basically on our long-term goals. A little bit of our applications architecture, how does it look like? It's not like the most accurate thing, but this is reflect a little bit of our design since we started. So we started developing, we don't call it one platform, so we built a platform that is, again, modern, microservices, etc. pp, but a lot of it is basically designing the software, where the thing should work, how it's supposed to communicate, what is basically our connectivities, etc. between the systems. We end up with a few things that basically it's fundamentally the layout. We call it the layout of basically our system. Some of it is API gateway, a lot of applications here, a lot of basically messaging in the other side. Then we basically have advanced analytics system. We don't call it that much of a big data, but a lot of it is basically advanced analytics capabilities. And basically, we have a lot of small applications in our back office that facilitate our day-to-day activities. We focus on three things, at least three things that we see them probably the most important things that we started with is autonomy. This was the first thing. The second thing was basically high availability and fault tolerance. And the third thing was basically continuous integration and continuous delivery. We believe that those top three things that basically contribute to us building a scalable platform and in the same time enable agile teams to deliver, enable the whole culture and the whole agility that we want to achieve, right? So our key was basically from the start. We started with very, very little people, and the only thing to achieve is to automate. We never look at how do we do something manual. We always look how do we automate it. So autonomy was basically for us is probably achieving the full autonomous, not in a single day, or it's basically in the whole life cycle of applications, of development, of delivery, everything that we deliver. One of our key components in the autonomy was the infrastructure. So we run a lot of this microservices, cloud-native applications, distributed, scalable, blah, blah, blah. One of the key challenges that we have is like, okay, how do we basically build the infrastructure? How do we design the infrastructure? Most of the time, we design applications, but we never design infrastructure that run onto it. So the key thing that here we started basically was building some logical components. Then we started automating the infrastructure. We used a lot of different technologies. We used, of course, we run AWS most of the time. We have different locations, but most of the inventory is in basically AWS. Then we used CloudFormation for some time. Then it was not that much flexible. We switched basically to Terraform. Then we basically migrated everything to Terraform. We have a lot of scripting around these things. The workflow looks like this exactly. So whenever we do some changes, we put them in basically source code control. Then we have basically autonomous deployment from our infrastructure. We want to scale up, scale down, add more components, add more APIs, add more microservices, systems, whatever it is. Everything goes through a code. So the moment we look at this, we never open, for example, the interface or the web browser to check the AWS console or whatever. Everything is code. We read it. We looked at it. A few things that we got from this is, of course, one of the key components was tagging, for example. We tag every single thing, every single resource. One of the things that we basically built was the security layer. So the security layer is built in. Everything has a network access control with the security groups, specific ports open and close, and we don't need so much time to maintain it. It was just looking at the code, changing the code, and just deploying the code. Everything is idempotent. We know what will happen before it happens. We know the outcome of the deployment before it happens. So it gave us a lot of flexibility, and it gets us to what we are now. The other part of this, of course, multi-inventory or multi-basically providers. So Terraform supports multiple providers. So we have some other providers that is basically also local infrastructure, VMs, different areas. And it's all in one place. So it's like a DSL. You just deploy it. It works in different providers. So this was the first thing. The second thing is a very common practice that we followed is we have agile teams. They deliver a lot of things, and we have like a lot of deployments happening per day. There is no schedule. It's just whenever we finish, we just deploy. The most important pattern that we had is it's a small microservices. It's communicate over HTTP, and whenever we deploy, this HTTP goes down. The application is not working, is not listening. So there was a lot of times that we have basically a little bit of non-availability. So the service is not available. Apart from, of course, building high availability, which is we deploy in different zones, different data centers, etc. PP. We deploy also in sequential mode. So whenever we have certain application that is basically deployed, we do deploy sequentially. So we remove certain things from the load balancer, blah, blah, blah. We put it in different areas. We noticed a different pattern that we could also achieve a little bit of availability and basically high availability that it will allow us, which is basically replacing some of this HTTP layer with a messaging layer. So a lot of time when we basically want to request certain endpoint, we actually connect to a queue system, whatever it is. For example, we use RabbitMQ a lot. We use Kafka for some time. So we connect to a queue system, and then the other system, whenever it starts listening and process these events, it's also communicate back to the other system. So we have acknowledgement, we have messages back. some sort of something like gRPC, so it's very similar concept, but basically through queues. It also allows a lot of developer flexibility, so instead of, for example, a developer want to test another system on development or in production, he doesn't need to run the system locally or in a virtual machine or whatever. He just connect to the queue, push the message, and receive other message, right? So it was a lot of flexibility that it gave us. It's a very, very nice pattern that we followed. It gave us a lot of flexibility and also a lot of developer flexibility. Go ahead.
Regarding the messaging, do you have a model to measure how many messages they're adding new services? I mean,
So-
are you linear upgrading the messages?
No, not really. No, not really. So a lot of the things we invested upfront in basically measuring the resources, the usage, how much we need, for example, to scale up for X messages. We do a lot of stress load testing. Yeah, basically, look, it's clustering, and yes, we horizontally scale if we need to. Most of the time, we have probably 3-4 machines that queues. So like for every cluster, for example, right? So it's never been like, hey, you send more messages, you just need to add another machines. It's never been like that, right? So there is always listening, there is consumptions. So you need to understand the messages, the load, or basically the benchmark happens when you have a lot of messages at the same time, right? But if you have some sort of a stream, so it's a lot of messages comes at the same time, you have clustering is not necessarily high availability, then you just can scale horizontally, right? So this is, yeah.
Well, I understood initially that messages are the only way to transfer the communication between services, right?
Yes, not only, but we move all the critical parts. For example, think about the customer want to pay. What if the payment service is not available? This is a critical part for us, right? The customer want to do X, Y, Z, something that is very critical to the business flow, that we want to basically maintain the availability no matter what, right? So this stuff, we moved it basically to some sort of messaging. So basically when we publish a message, once it's processed, or it timeout, right? And then we have a fallback to HTTP as well, okay? Cool, so this was basically the second basically pattern that we have developed. The third pattern that we started with, a lot of it is, a lot of the stuff has been done before, right? But the difference when we do it in a probably a unique way that is reflect our use case, and it allows also for more flexibility, and it contribute back to building the teams, right? So we always focus on the people and the teams. How can we give them basically more flexibility, more what we call it developer experience, better developer experience. So you think of a user experience, we have a development experience as well, right? Yeah, everyone believes in one button to deploy everything. I mean, this is the ultimate goal for everybody, and yeah, we fulfill this goal. Everyone believed in this. This is our also core value. The first thing is we have, I mean, there is a lot of tools in the market. There is so much tool that does a lot of different things. Yeah, there is always, you know, pros and cons and discussions, and we use this or we use that. Yeah, we don't like confusion, so we build our own, right? So this is what we, yeah, exactly. So this was basically the key. We build our own using, of course, there is the very, very famous tool Jenkins. We use another basically continuous integration platform called TeamCity. It's very also famous. And we build on some sort of system or an API around these tools to integrate it. So basically, it's an API. So we build another API on top of both the tools to basically give us the flexibility. So the pattern here that you see is we have a very standard. It's not very standard, but it's more of around our workflows. So a standard CI and continuous delivery, basically pipelines. But it's not the basic one. A lot of these questions we get is like, hey, let's use whatever, Circle CI. Let's use whatever, Heroku. Let's use whatever we use. The question we ask is, okay, if we spend some time to learn that system, it's better for us to write our own system, for example. Yeah, so you spend more time figuring out, writing bash scripts, writing other scripts just to achieve one thing, while you could just quickly write a code that does this thing, right? So what we did is, so the key for this was basically, for us is, we want to achieve fast code reviews, fast releases. So we have a branch that is whatever, developed, merged, and blah, 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 somewhere. We want to look what is the results in there. Other people do peer reviews. Other people look at different branches. What happens is you have to check out the branch, get the thing, run the test, do whatever migration, do a lot of other things, just to know what was the result of, for example, the tests. What was the result of whatever, the flow that you are doing. So what we did is we took GitHub, then we built a lot of bots. Then we basically automate all this testing. Then we post the nodes to GitHub again. So to the pull request, basically. So we have a pull request. Then we have a lot of bots that basically, as you see here, it posts basically the linting, the code sniffers. And then we implement another pattern because a lot of this thing is microservice, a lot of it is API oriented. And the most important thing in the API is the flow. So if you have 5, 6 APIs, you need to make sure that every API work alone. So if there is the payment system, it need to, with 5, 6 integrations, it need to make sure that this 5, 6 integrations are working. So think of an integration test, but in the API level, and it implicitly tests a lot of things. So we have, of course, authentication API, for example. It handles authorization, configurations, permissions between the APIs. Then we have the normal, basically. So this is something for flight integration, for example. So we have like all this normal things. Then we have in the end like an API flow. This API flow books actually a flight. A real flight from the same applications is not in the UI level. So this is not an end-to-end testing, but it's an API testing. And of course, implicitly, it tests a lot of things. It tests the payment, it tests the search, it tests the database, it tests whatever it tests. Then we, of course, book multiple flights, for example. So then when we do code reviews, we want to release, we want to blah, blah, blah. Then the first thing that we look at is this results. This is basically our first thing. Then once we see something here, we try to investigate, or we try basically to run or whatever. Now what we achieved with this is probably the one button merge as well. We don't need to run a lot of code, a lot of peer reviews. We just look at the results, and we keep add linting checks, and there is a lot of other checks as well, check configuration checks, whatever. So there is a lot of steps that we can just add just to ensure, we call it prevention measures, to ensure basically quality, no bugs in production, etc. BB. Yeah, this was basically, again, all of this was basically around, a lot of it is the developer experience. We want to provide a developer experience, fast feedback, so the developer himself can get notifications. The good pattern of this also that introduced is we can have a lot of reviews in the same PR, for example, that they are interested in this PR, some of them in the payment team, some of them in the whatever, CMS team, whatever it is. They just go subscribe to the pull request, they watch the results. They don't need to go and look at the whole system, look at the whole code base just to figure out if this is working or not working, right? So yeah, visibility, better development experience, fast feedback for the developers. Yeah, we cut a lot of the time basically due to deployments, to testing, to basically merging branches. Yeah, part of this, of course, this is mainly handled by our release engineering team. So we have a release engineering team that basically they do this and improve it every day by day. Yeah, that's pretty much 3 things that we covered. Yeah, it helped us a lot to basically build and scale. Yeah, thank you very much for listening. You can go ahead.
Number one, I'd like to ask about, are you using any containers?
Sorry, any containers?
Yes.
Yeah, we use a lot of containers. So so okay, a little bit of things here. Yeah, I mean the technologies are not covered here. We'll probably use everything as mostly everything. One of the patterns that we follow is we have a lot of containers running, not only in production, also in development, in also local machines. Our development machines, in every development is Docker compose file that contains of all our images. All the CI is in Docker, and again we build it as well. It's Swarm cluster that we run basically from our own CI API. The other parts is, as I told you, we have a lot of components in production, also in Docker, maintained basically by Swarm, if this was the question. We were looking basically at Kubernetes, etc., but all of them basically cover the same thing. For us, I mean, if you build a Docker, you can run it anywhere. You wanna run, yeah.
So how to manage such chaos for a lot of services running around you?
We follow single responsibility. So we have people responsible for one thing and one thing only. Now managing, yeah, go ahead.
I mean, automate managing the chaos results from such amount of services running all the time.
Like what? Okay, so we have, okay, if logs, for example, what are you talking about?
Chaos for.
There is no chaos. This is exactly what I'm telling you. Yeah, exactly. So definitely. This is actually a good thing. So look, look, it's microservice, a lot of it chaos, right?
Yeah.
But it's chaos only if you go off boundaries, okay? And this is where we implemented this. This is where we put a lot of time here, right? So we put a lot of time, we call it design. So this is a software design. we put a lot of time designing how our application will work, where this application will fit in, how it will communicate with other world. One of the one of the few things that we do is, for example, when we have an API here, we also implement an SDK to connect to it. So no one goes and just, hey, connect to the API as you want. No, everyone, so flights has an SDK, hotels has an SDK that when somebody else using it, he used the SDK. He never knew how to connect. So like whatever, search flights. This is basically the method or the function code, right? So we have the API, we have the SDK, and anything that we think of beforehand, so it's not like, hey, go and do an API or go and do a microservice. Okay, no, we think about it, we put it one of these boxes.
I think you didn't get me. I'm talking about whenever you have automation for each part, and whenever you are adding new stuff, it means managing this stuff with automation, it create a lot of messaging between around the system. And then to manage a system with such a scale, create a lot of chaos as well.
Whenever
there's a lot of pizza.
Yeah. Okay. Yeah. Sorry, it took so much time, but yeah, we can follow up after that. Yeah. Usually there is no chaos. Thank you, guys. Thank you very much. Thank you.